When routing a new piping line, you eventually hit the same fork in the road. Specify a butt weld or a socket weld fitting. They both move fluid, but that is where the similarities end. Butt welds are built under ASME B16.9, while socket welds fall under B16.11. These separate standards exist because the underlying structural reality of each joint is entirely different. Left, a butt weld penetrates the wall, creating continuous metal. Right, a socket weld uses a recessed bore sealed by an exterior fillet weld. Both hold initial pressure, but the wrong choice causes undetected fatigue cracks at the fillet toe or crevice corrosion leaks. To avoid those long-term failures, we are going to build a definitive framework combining ASME B31.3 restrictions, inspection realities, and joint geometry to help you specify the correct fitting every time. Ultimately, this decision comes down to balancing the immediate ease of fabrication against the long-term integrity of the joint. The first hard limit is physical size. Butt weld fittings scale smoothly all the way up to an NPS 48 pipeline. Socket weld fittings, by code, hit an absolute ceiling at NPS 4. When you look at this cross-section of a butt weld fitting, notice how the wall aligns perfectly with the standard pipe schedule. Because it matches the pipe thickness exactly, it carries the exact same pressure rating as the straight pipe itself. Socket weld fittings handle pressure differently. They don't use pipe schedules directly. Instead, they rely on fixed class ratings, specifically Class 3000, 6000, or 9000. This table shows what those classes actually mean. They are bore matching indices. Class 3000 correlates directly to the outer diameter of Schedule 80 pipe. Class 6000 is machined for Schedule 160, and Class 9000 is bored for double extra strong pipe. If you try to pair a Class 3000 socket fitting with a thinner Schedule 40 pipe, the math breaks down. Because the Schedule 40 pipe is too thin for the bore, it leaves an oversized, irregular gap inside the fitting. That gap ruins the profile of the fillet weld. To make the physical fit-up work, choosing a socket weld forces you to specify a minimum of Schedule 80 pipe, even if the internal pressure of your fluid only required Schedule 40. Socket welds give you the convenience of standardized small-bore inventory, but they force unnecessary weight and material costs onto your lines compared to the exact match flexibility you get with a butt weld. Pressure is only half the equation. We have to look at how these fittings handle mechanical load, vibration, and thermal cycling. In this diagram of a butt weld, the stress flow lines pass horizontally straight through the weld metal. There is no interruption in the load path. Because the geometry is continuous, a butt weld carries a stress intensification factor, or SIF, of approximately 1.2. The metal handles the load easily. Now watch what happens in a socket weld. The stress lines travel down the pipe, hit the 90-degree socket face, and bend sharply outward. All that force congregates at a single point, the toe of the fillet weld. That severe geometric discontinuity concentrates the stress. It nearly doubles the local load, pushing the stress intensification factor up to 2.1. The reason fabricators accept that weaker geometry is speed. A socket weld offers a forgiving, slip-in fit-up that takes minutes to prep, whereas a butt weld demands precise beveling and root gap control. That lower skill threshold is highly attractive when a project needs to prioritize labor hours over joint complexity. But the ease of that fit-up comes at a direct cost. Under heavy vibration or repeated thermal cycling, the survival rate of a socket weld drops drastically compared to a butt weld. Once the joint is welded, the QA and QC inspectors have to verify its integrity. This diagram shows a radiographic beam passing cleanly through the single, uniform wall thickness of a butt weld. The resulting film clearly proves the internal soundness of the joint. This clean view makes butt welds fully compatible with volumetric inspection methods, giving you absolute certainty about the inside of the weld. When that same radiographic beam hits a socket weld, it has to pass through overlapping pipe and fitting walls. The image on the film comes out muddy, superimposed, and entirely unreadable. That overlap leaves inspectors blind to internal defects. They are forced to rely on superficial surface tests, like dye penetrant, to clear the joint. Socket welds also come with a strict ASME physical requirement. The fabricator must leave a 1/6 inch gap at the base of the socket before welding. That gap gives the pipe room to expand firmly without cracking the weld as it cools. But once the line is in service, that required gap becomes a permanent, stagnant crevice. Specifying a socket weld means you are deliberately accepting a joint that cannot be radiographed, and one that houses a permanent trap for localized crevice corrosion. We can combine these mechanical and inspection realities into a practical decision framework for your isometric drawings. Here is how the decision tree flows. The first filter is pipe size. If your line is larger than NPS 4, the ASME code dictates a butt weld automatically. Next is the severe cyclic service filter. If the pipe is above NPS 2 and subject to heavy thermal shocks or mechanical vibration, B31.3 restricts socket welds. You route to butt weld. Then check your inspection requirements. If the project specification demands radiography for critical hazard fluids, you route to butt weld. Finally, consider fluid corrosivity. If the line carries chlorides, sour fluids, or anything prone to crevice corrosion, you route to butt weld. If your line clears all those filters, meaning it is small bore, non-cyclic, and carrying clean utility or instrument air, it successfully routes to a socket weld. In those safe applications, socket welds are the perfect tool. They offer fabrication efficiency for densely packed instrument headers with dozens of small branch connections. But for large bore piping and critical hazard fluids, the long-term reliability and verifiable inspection of a butt weld is an absolute necessity. Let the fluid service and the piping code make the decision for you. The immediate cheapness of a socket weld fit-up is never worth the lifelong cost of a hidden failure.